Oh, hi guys. Sorry for being a bit late. I had a sudden weird telephone call I need to attend to. Yes. So one of the aspects we talked about last session was assignment 2, right? I know you had, it's mostly around assignment 1. Did anyone had a chance, if you could switch off the monitors, did anyone have a chance to look at assignment 2, to get a feel of what's going on? Yes? I know someone did, yes? Yeah. You have? And you have made some suggestions, that was good, right? Saw that well? Someone else? Who did not have a chance to look at it yet? Okay, right. Did you discover any other bugs or issues? Not yet? Okay, that's scary. Okay, not yet is always scary. You have found.
One thing I was wondering about, how are I supposed to deliver assignment 1?
Yeah, that's a good question. That's right. That's
would be the redirects it to the main page, and I see nothing about it.
That's right. That's right. There's nothing there yet. That's correct. We get to that. That's step number 2. But now step number 1 still. Okay. Did anyone think about how to solve assignment 2? Somewhat.
I'm just going to remember the deadline.
I put it, all right, that's a good one. I put a deadline on the 1st of November in 2019. Yes. That should be feasible. It's a Friday. Yeah, so that's the idea. Okay, well, since you guys are avidly working on the first assignment and haven't put your mind to the second one yet, it's probably worthwhile discussing it next week then. First assignment, right. So, yeah, most of you will be busy doing this right now. Submission was one point. And as part of the submission, we'll probably need to deal with the problem of how to do it, right? So we haven't provided the system yet, but it will be up soon, and it will look something up. Person. It will be hosted in open cloud right now, so it's not really a publicly available solution. The main point you need to bear in mind that in order to log on, you will need to be on the NTNU network. The system will also look something like this. I'll send out the URL soon. And the idea is there that that you see the course and you see associated assignments, right? So, and right now I have demoed here 2 assignments, assignment 1 and assignment 2. And you would then be able to actually click onto assignment 1, which will be the assignment we're currently working on, and simply deliver the assignment. And as part of the delivery, we're asking you for 3 things. One of them is the URL. Sorry, please.
Can you log in via the NTNU VPN?
That's correct.
Yeah.
So you need to be on the NTNU network, which includes, that's right, the VPN. So, right, how many of you are aware that NTNU sponsors a VPN for you? Good. How many set it up? Good. So that's good. Vast majority. Yes, definitely. So I'll probably post a link on this one as well. Hang on, we'll make it easy. But I'll just show you how to get there. You go to INSEA and just type, guess what, VPN. And you get a, in any language of choice, you get an instruction how to set up an Windows and Mac in particular. One aspect to bear in mind, if you're dealing with Linux, if you're dealing with Linux, particular Debian-based installation, don't download anything, just use the packages that come with the distribution as far as possible. Here's the example for Debian-based installation. So if you run Ubuntu, Mint, or Debian, of course, then it's very straightforward. I'm not sure how it runs on Arch, but we have an expert. Sorry? OpenVPN, okay. Cool. So you just install OpenVPN. So the Linux people should be a bit mindful, not just download the software from Cisco, because else you have proprietary software on the system, I think, and you may not want that depending on your attitude towards that. Other than that, the Windows side, for example, is relatively straightforward. You literally download the installation and install it on your system, and then you provide, you enter a new username and password when you want to connect. And then you have access to the well, to OpenStack installations, for example, that we'll be dealing with as well. So you need it for the course anyway, so it's worthwhile to install it. So if you haven't had any exposure to it yet, please do so. So that was a good injection there. Right, coming back to the assignment. So you'll only see that if you're really logged onto the VPN or on the current local network. So what you need to submit for your submission is quite straightforward. There is the URL to your Git repository. Main thing is ensure that this thing is public. That's the common mistake that we have, that people post their URL, which is good, but they don't make it public, right? Because the idea is that someone needs to be able to review it, and we need to be able to do that. The second one is the URL to the Heroku instance, right? One of the tasks was to deploy it on Heroku. If you manage to do that, that's where the Heroku instance goes. So, people can just test your system, have a look at it. And the last aspect is you can leave some comments. Sometimes people want to say, well, I nearly got done, but this doesn't quite work, or sometimes I have this issue or something, or whatever else. Provide some information to potential reviewers so they know it in advance. That's where the comments box is on for. If nothing needs to be commented on, then you'll be fine. In terms of comments, I discovered an interesting error that even though the comments field is not mandatory, the system treats it as mandatory. So some bug we need to work on. Just put anything else, like type OK or whatever, just to fill that. So if you get a 400, but in submitting it, it most likely means you didn't fill all the fields, and it's annoying. But again, this system is also, a product of work here, so it's under development as usual. So that's pretty much it for the submission bit. Not terribly hard. Sounds okay, right? So note that those fields validate on URLs. So if you get an error, it most likely means that you don't have a valid URL, right? So you have your unnecessary spaces left or right or in between or whatever else, or you forgot the HTTP or things like that. So I forgot how flexible the regex is on this one, but it fundamentally checks for URL input, so it's quite important. So. URL, so ensure that you get it right, and probably just test it as well that you submit it, and then you're fine. Note, you can submit as often as you want, right? So technically it shouldn't matter, because you can submit your URL now, who cares, right? And then it's still the same URL, hopefully, during the time of submission. But you can submit or even withdraw the solution at any time as well. Right? So we don't constrain you to submit only once. So once you get access to the system, you can just start using it. Okay, so with this in mind, it's probably time to give you access to the system as well, so you can start playing with this. I'll give you 5 minutes to break it. Hopefully you don't. In the past, we were successful using it, so let's see if we just figure out the link to this. In order to join the system, of course, you're wondering, okay, how do I get access to all this thing and so on? The principle is relatively easy. You get a link, which I'm cryptic. I'll probably post this on Discord. And I'm not sharing it on the stream. Guess why? Right. So that's the idea. So let's see if we find this. Shouldn't terribly be an issue, because technically be an issue, because people can only join when they are on the NTNU network, but you never know. Right. Yeah, where's Cloud? Where's Cloud? Where's Cloud? There you go. Does anyone see it? Programming in Jorvik, and then there should be a link. That's somewhat cryptic. When you press on that link, you will be redirected to the system and asked to create an account. Ideally, use your NTNU email address and a password of your choice when you create the account. Note that you get an email on this email account, so please use a valid one, that you need to confirm. So, and once you are confirmed, you have access to the cloud course. If you don't use that link that I provided you and you just go to system, which is the URL 10.212 to 137.55, you can sign up for the system, but you won't see the cloud course because the system is generic. It could be used for any courses, right? But only with this link can you access the actual cloud course. Good. I'll let you play around with this. I think that's should be that for now. Any questions so far? Please. VPN. Right. So the idea is that resources that we are hosting inside the NTNU network are not necessarily always openly accessible, right? So even though we have IP addresses that are allocated here as part of our OpenStack arrangement and so on, they may only be accessible from the inside, right, from the network. So right now you're connected via Wi-Fi and so on. The idea of VPN is to be able to remotely connect to private networks, right? So the NTNU network is considered private in that respect. But in order to access resources that are inside, we would either need to allocate a public IP, which NTNU has some of, but you know they're scarce and expensive. And of course, they expose the system directly to the public, meaning to anyone. So if anyone gets wind of for example, the link and so on, they would be able to sign up for the system, for example, or we would suddenly be subject to DDoS attacks or whatever else. So we'll kind of host it internally. And what you will need to do in turn is to install a client on your system. So it's something you need to install on your machine that connects to the NTNU network and behaves as if it is part of the private network, even though you're remote, you're offsite. So meaning you don't need to do that when you're here, everything will work. But when you're sitting at home, you suddenly realize, oh, damn, the submission system is down. But it's not. It's actually just that you need to activate your VPN connection, right? And it's literally really straightforward. If you're running Windows, it's a one-click installation, nearly. So you just press, install and so on, and then you get a small icon. In fact, if you look at my screen, it's this one here. Just bring it up. That's how it looks like. And then it has pre-populated the URL for NTNU. It's vpn.ntnu.no. You just click connect, and when you do that, it will ask you for your username and password. Similar to the ones you have to use for logging on here. If you're using, for example, EduRoam as well, that's the kind of credentials you can use. So I'm not clicking on connect so as not to expose my credentials. But so that's the whole idea. And once you're connected, you will see that on the bottom right on your machine, especially talking about Windows, or top right in Linux, in Ubuntu, what the connectivity is like. And then you should be able to access this IP. I mean, the sanity check is simply to take this IP and see if you can access it from home, and then you know, yeah, my VPN is working. Yeah. And the instructions for this are completely on INSEA. Right? You guys use INSEA? Or you know about INSEA, but you don't use INSEA? I know. Sorry? You use it? That's good. But if you type, it's actually quite helpful when it's about resources. If you type VPN there, you quickly be pointed to the right location and get some setup help there as well. But this system is fundamentally managed by IT. So if you have problems with this one, you need to talk to those guys because they know and can look into the logs and so on, figure out why you can't connect. But generally, it should be relatively straightforward. In any case, you need to set that up eventually. Please. Sorry? That's correct. That's another reason why we host it internally. Very good point. Yeah. Yeah. We have another few, how do we call them? Feature? We need to address. So there are a few glitches we're still working on, working out. That's right. But yeah, we should probably HTTPS secure that a bit more as well. So that's another sensible reason for not exposing it publicly. That's right. Cool. Did anyone get in already? No? Good. Well, I'll let you guys play around and figure it out until the end. Good. So tomorrow we do a complete session basically just on QA, right, to wrap up, because that will be the last session we have, right? Yeah. Cool. What I wanted to do before that is to to give you to further our little discussion on the theory side as well, because we need to do that as well. We can't just drift off entirely into the lab or the assignment. And tomorrow we briefly also talk about the idea of code reviews. So we make that a bit of a combined session, so everyone has an understanding what they're up against after the submission deadline. I originally thought we could do it after submission deadline. Why not do it earlier? So next week we can look at other topics that are relevant for your second assignment. Because there's always something that's more pressing then, of course, once the deadline has passed. Okay. So we briefly touched. So here's the theory bit. We briefly touched on infrastructure as a service in the last, previous Wednesday, I believe we talked about this, right? So because that's really the third aspect or the third chapter, if you like, of this course that we're entering in a way. You have some exposure to platform as a service. Well, even if not, you will have some exposure after this weekend's submission because you need to run it on Heroku, so that would be platform as a service. But in order to understand infrastructure as a service a bit more and be comfortable around the terminology, we need to highlight some aspects that are relevant to it because it's so much the synonym, it's kind of the pinnacle of cloud computing to understand what some of those aspects are really about. And we informally talked about the importance that infrastructure as a service provides the whole stack, the computational stack, starting from the virtualized hardware, of course, which usually consists of 3 components, which are, classic exam question. What are the 3 components you would first, I believe? You're still reflecting? You just wanted to save the spot? Okay. Okay, your turn?
Processing.
Yeah?
Storage.
Yeah.
Memory.
Not quite. Third one?
Network.
Yes, that's right. So usually, yeah, that's right. I mean, from operating systems point of view, you're right. Memory is treated separately from processing. But from a virtualization, cloud virtualization point of view, it's generally the tripartite differentiation into processing, storage, and communication, there, networking, right? There was a comment there? No. Okay, so processing, storage, networking. Those are usually the 3 components that are virtualized, right? Instead of getting this in hardware, as you would in a conventional data center, the idea is to virtualize those completely. And on top of this, what do we do on top of this? What's virtualized on top of the hardware? Operating system, right? What came above that? Yeah? Yeah, exactly. Yeah. So generally, the differentiation, so you're on the right track there. The differentiation between service and application is usually that applications are often targeted at end users and services oftentimes not, right? So they're also provided, but they're more like for administrators in a way or whatever else, but they facilitate something for users, but not necessarily are the end user app kind of thing. Assignment 1 is like yeah, absolutely. Yes, absolutely. Yeah. So we're developing a service. That's correct. So we're not dealing with the end user per se. It's always a matter of perspective, right? So it's kind of a fluent concept, but fundamentally it's a service. That's correct. And we talk about the flexibility that comes about and actually having a cloud service based or a completely virtualized infrastructure, right? So we can. Why is it so flexible? Why am I talking anyway? Or is it flexible? Oh, you first. Okay. Back to you.
We can change the amount of resources to give the user whenever it's needed. For 1 second it needs connection to 50 people, the other second needs connection to 1,000 people.
Exactly, right? So this example is good, right? Because it's showing the dimension, right? And which you need to be dealing with. So it needs to be a sudden response to changing demand, right? So and that's much more common nowadays since we have a larger number of devices on the internet in the first place, but also that applications don't have this extended life cycle anymore, right? It's often then that we have startups that are lucky in getting one successful game or whatever else out, and they have really a peak use, and then suddenly there's a decay, right? So you don't want to hold the resources, meaning you don't want to buy machines to sustain this peak. But actually you just want to perhaps have your own resources to sustain your average use level, right? So, but you can use cloud technology actually to alleviate this aspect. Yeah. So that's the main point, being able to respond to it. What's the other thing? What's another thing that's quite relevant from administrative point of view? Over time, for example, if your application grows, what do you want to get more? Yep. Yeah. So yeah, that's right. You need more space, but you also need more processing, and you may need higher bandwidth as well, right? So it falls in a similar category. But what is fundamentally the idea of IaaS in contrast to platform as a service arrangements? Yes, that's the scalability aspect. It's all, yeah, that's right. It's the right answer. I'm looking for a different aspect of it. So the ones of you that actually potentially run, especially if you have an operations and drift background, what do you gain more by running infrastructure as a service environment?
More control and customer service that you also need with the operating system by itself.
Exactly, right? So suddenly that's the point, your control, right? You have pretty much control of the entire stack, which you don't have in all other cases, right? You have some sort of, let's give a bit more space, or give some bit better networking connectivity, or use different, virtual hard drives or whatever else. But here you actually have full control, right? You can go back to your machine, whatever that means really, and reconfigure it, provide more RAM potentially, right? So, or switch off the hard drive, extend the volumes and so on. Introduce concepts such as load balancing, which again also exists to some extent in platform as a service arrangements. But here you really have the full control that you would have with a conventional machine. And that becomes more interesting if your systems grow actually, and if you have more different components, because then you can tune according to your system's specifics, right? If you're of course running one service, okay, it's not much magic there. I think you probably get away with the PaaS platform initially, but if you your system becomes more complex, then it's important to deal with this as well. So that's what two main motivations for going down the IaaS route: so scalability and control, one of the aspects. And there's a lot of words always thrown around that are generally used. I mean, one of them is scalability, we have manageability, to some extent, accessibility, performance, optimization, and reliability. And the question is, so, of course, those are all terms, but what does it mean in the context of infrastructure as a service, right? So we have some sort of intuitive understanding. For example, in the area of scalability, we would think about an on-demand increase in resource availability, right? So there should be a very fast provision of additional resources if you need them. And the interesting, or the main point is, under the assumption that the system behaves the same, right? So you shouldn't see any difference in the system behavior independent as to whether it runs with 50 users or 1 million users. That's the main point of view. So the system is not necessarily getting faster as such, but it's rather able to deal with higher load, right? So that's important aspect there to bear in mind. If you look at the three components that we're dealing with, that would be processing, storage, and networking. What does it mean? Well, in the processing case, you of course need to be able to create dynamically virtual machines, right? So that can be spun up and spun down and replicate some of your service logic, most likely. You want to be able to control those virtual machines systematically by integrating so-called hypervisors. We didn't talk about this yet. We'll talk about it in another session. But the idea is that you have full-grained control. Similar for storage, you want to be able to reduce and extend storage. One of the techniques that you apply there is the concept of thin provisioning. Some of you may have heard about it in, I don't know, structure as code or thin provisioning. Did anyone talk about this before? So the idea of thin provisioning is quite straightforward. So we are now dealing, in the context of infrastructure as a service, dealing with virtual machines, right? So generally you would have something like a, you're reserving a 8-core, 32 gigabyte RAM machine with, I don't know, you name it, 500 gig of disk or whatever else, right? So And even if you use 20 gig of this, for example, such as you'll be allocated here in this context of in OpenStack, you most likely will not use the whole disk space, right? I mean, no one should ever use their whole disk space because most likely their system will not run anymore, right, at that stage, right? So we always use at best half of it or perhaps a bit more. But in all cases, you will be very unlikely to actually use your storage entirely. And what does it mean for cloud providers? And that's where they actually make, well, to some extent make money. They use thin provisioning because they only allocate the resources you actually use. So assuming you're subscribing or instantiating a 500 gigabyte hard drive, whatever else, right? But you're only using 10 gigabyte of this, right? They technically only provision 10 gigabyte of this. So all the 490 gigabyte that you also have a right to use is provisioned possibly to someone else. You wouldn't know. It's just the ability of the data center to reassign it to you when you actually need it. But it allows you to actually flexibly use the data space. So here's a kind of a good visualization that I found that highlights it quite well. So if you have, for example, thick provisioning as a concept, it would mean that if you have two tenants, so two clients in your system, for example, the left side shows that we have volume A and volume B, we have data, and we have unused space on a particular partition. Assuming you have one, storage resource, one giant storage resource, for example, 1 terabyte, and they split it up into 500 gigabyte hard drives, well, you technically don't need to fully allocate the 500 gigabytes to each of your clients, right? You simply allocate what they actually use. So you ignore the unused storage initially and just allocate what they actually use. So in this case, you have a massive saving in terms of used resources. So theoretically, if you monitor the usage pattern across all your tenants, across all your clients, people that actually rent space with you, and see, hey, they only use about 25% of the allocated space in all cases. And that's often not surprising because the hard drive is generally allocated at fixed sizes. So you use only a considerable subset of it. They could simply suddenly, with the same storage, would be able to serve 4 tenants, right? Because so for them, it basically means they're halving the load on the physical resources they actually need. And now you're suggesting, yeah, okay, that sounds good, but what happens if your first tenant suddenly has higher demand for faster space? How do you deal with this, right? So the idea there is, well, you need to see this over a large number of clients. We're talking about millions of clients, and across those, you generally have a reasonably stable pattern that you will never use up the entire allocated space. So you will always be able to switch around and basically reallocate space from a different volume, if you like, from a different tenant to a respective other tenant, because no one will use up their space entirely, right? And even if you suddenly exceed your data volume that's allocated on a given, let's say, physical hard drive, if you want to think in those terms, then the client will be allocated space, of course, on a different physical resource, on a different hard drive. Because in the end, fundamentally, of course, the data is stored in some sort of storage area network, SANs, or even physical media. So we talked about the different ways in which things are stored in the data center as well. But that's the key idea of thin provisioning. Only allocate the user as much as they need, but be able to allocate more if they demand for it, right? But in this slide, especially for initial stages, when people build up their systems, and you provide the initial storage, for example, they're installing their system initially, you can really heavily capitalize on using thin provisioning as a cloud provider, because you simply don't need to hold those resources. Theoretically, you don't need to hold those resources at all, assuming that those never grow, but that's the idea. Yeah, so that's something they're really playing with. But even if you are in our environment here, we're running OpenStack at NTNU, they do the same. So if you go to the administrators and actually ask them, hey guys, how's the load of the actual systems? They will tell you, well, that the actual load in terms of storage probably sits around 10% of what's allocated, right? So you can suddenly see if you only use 10% of your allocated volume, well, you suddenly can host 10 times as many people, right, theoretically, on the system. And they consider this, right, the average load in storage. Of course, you need to have reserve capacity to some extent, but you never need to have in practice, you will never need to have the full capacity because no one will exploit their volume in its entirety in practice. So that's the key idea here. So that's the idea between thick provisioning, meaning giving the full resource. So if you buy a PC, you get, that's thick provisioning, right? You get the full 500 gigabytes, whether you use them or not, on you, right? In cloud environments, we use thin provisioning because we can allocate storage on the fly, right? So even though the user will not notice it at all. Any questions regarding this? Please.
So you said that they give more storage when they need it,
Yeah.
and they use the rest of it something else. But will they ever say something if they always have reserved in case demand is high?
So,
But like all cloud services have like a little less than they actually should have, because they know that they want to use later.
so that's the thing we don't quite know really, right? Because that's part of the business model to some extent. But in practice, you can expect that, yes, that people will say that we are under provisioning and actually probably giving out more. It's a bit like the airlines overbooking, right? So phenomenon that they're actually allocating more space than they physically have at avail. So in the least case, even if you maintain resources, it may mean that you don't need to run the resources at all times, right? If you have a storage area networks, you don't need to run all the nodes at all times because you know, okay, well, I have 5 minutes to start them up in case I ever need them, right? That kind of thinking, and it's quite flexible in this arrangement. It's a tough one, yeah.
Still have all the set down on me, not all that.
Exactly, right? So you just switch them off or on, and if you can just automate this, of course, as well. But even if it would mean I need to physically start up, a disk, that would be kind of manageable within a given time frame. But the point is, you get warnings on this one. It's not suddenly that everyone. That's the thing. If you deal with large number of machines, it's not everyone will spike and suddenly claim their demand. It will be, there will be some demand here, and then will be some demand elsewhere, right? So it's really about the distribution. That only works if you have a large number of clients, basically, that are independent of each other, right? So in practice, they will not increase the demand at all times. So there's always enough time for you to anticipate, oh, right, we are, for example, reaching a threshold of using 75% of currently allocated storage, 75% of physically connected storage. So we need to add another 25 or 10% or whatever else, right? So there's a lot of on this. So monitoring is a big part of this, right? Keeping track of this. It's not that suddenly everyone has this demand, especially on storage. What's more problematic is, of course, networking and processing, where demands are indeed more sudden. But in storage, you simply can't store as fast as you would probably exploit the allocated memory. So they will be faster in allocating than you will be in storing your data there, especially since your data are transmitted via networks. So anyway, so that was one of the aspects there. So thin provisioning is very common, especially for the initial allocation, because that's it's mostly about figuring out how much you actually use, because you don't quite know. Yes, you have operating system plus X. What is X, right? And that will be figured out within a week of allocation usually. Then you kind of know that's roughly the load you need to expect for this particular client, and that's when you can kind of harden the allocation a bit more. Other aspects of networking is quite interesting. So there come a lot of challenges. So you need to be able to extend the networking or attach networks on demand, right? So the user shouldn't notice that you're actually attaching additional virtual machines and make them available to the client at runtime, right? That's one of the challenges there as well. How can you avoid that you have a 404 suddenly, or simply the unavailability of a server in the data center, and give the clients the appeal as if everything runs as on one giant server, right? So, and actually it doesn't have any disruptions. Whereas in reality, you're actually dealing with multiple virtual machines that are booted, right? Actually started and then virtually connected to the actual network, right? So, it goes alongside, of course, but it's a quite challenging task in its own right. And of course, dealing with routing where necessary to accommodate. That's similar to availability and reliability. One of the expectations is that clients should never think about hardware failure. So, whether you actually have a natural disaster or you actually have a hardware failure, the client should never need to notice. That's part of the deal when you're hosting with a cloud provider. You don't think about hardware. Because, of course, in the end, there's always hardware at the bottom line. So, there need to be some servers on which the whole system is running that provide necessarily storage and the processing capability, RAM, and so on. But you should never need to need to worry about it. In fact, in many cases, you wouldn't even know the hardware specs you're running on. In some data centers, you of course do, but in many you actually don't. You just know roughly, okay, how many CPUs do I have, how much RAM do I have, and that's roughly all I care about. So from a data center point of view, that's of course also a challenge there, how to deal with those aspects. Yeah, and it extends, of course, as always, to communication as well. So how did I deal with this? Well, the main thing is about dealing with monitoring, right? It's really about keeping track of what's the current load of the system, and potentially how to anticipate that we have probably problems, automatically backup virtual machines. So even though you probably need to pay for a backup service yourself, if you hosting with AWS, if you want to run it, they actually internally will do a backup anyway, because in case they need to migrate your machine to a different location because of natural disaster outages or whatever else, they need to be able to do that, right? It's just you don't have explicit control about it, but fundamentally is that of course exists certain backups to facilitate it. And of course migrating virtual machines, perhaps even maintaining redundant version of your virtual machines in order to bring them up quickly when there's actually demand as well. And similar for data replication. I'm not sure if you learned this in the databases course, but the idea of keeping data sources redundantly is one of the practices as well. So so even MySQL can do that as well, right? So it can distribute and ensure that databases are synchronized across different endpoints, different servers, MySQL servers, for example. But of course, they use different techniques in this context. But the idea is basically that your file system is replicated across different physical storage locations and devices, of course. One of the specific aspects here is that you, of course, should take into account as well as if you run your own data center, also responsible for it, is to think about physical locations, right? So you want to keep data physically separated. And one of the benefits of cloud services that gives them the illusion of reliability is really that they can afford to store data across vast geographic locations, right? So they can actually hold your data in US as well as they can in Europe and potentially in Asia. So your risk of losing the data is considerably lower than you traditionally, for example, running it in your data center and having some sort of redundant data center like 50 kilometers off, your actual location. So in which case you could still be subject to natural disasters and suffer loss of your data, right? So that's the key benefit. You can migrate globally. That's the key idea. So that's the availability aspects, how it's operationalized. The interoperability is another one that you want to be. That's where the user can come back into the situation, because in the other cases it's really more focused on the cloud provider. But the manageability is allowing you full control to resources. So that's one of the features of IaaS, of course, to platform as a service. Please. Well, your virtual machine is represented in it's in a file. So, for example, if you're running VirtualBox in your machine, you'll see that the complete file system is stored in in one single file de facto, and it depends on which standard you use. There's MK. Different file formats. I don't know the top of my head right now. But for example, for VirtualBox, for VMware player, and so on, Amazon has its own format, and so on. So that's the kind of the file that they basically ship across and replicate, and also keep in storage, so they can quickly instantiate your machine. And this contains your complete runtime system, right? So it's basically your virtual hardware environment that they can quickly instantiate again. This file is basically shipped around. Do you run VirtualBox in your machine? No. Does anyone run VirtualBox? Yes, you run VirtualBox, right? Have you observed how data is stored in VirtualBox? Yes. No, well, weird. I don't know, but it's definitely a file format. Yes. Let's see if I can spin. So, for example, here there's the virtual disk image format that comes from that's native to VirtualBox, and that's pretty much where they store your entire file system, right? So that's basically containing your hard drive, and then in addition to that, they have this VBox file. That's a virtual machine definition. That's actually an XML file. If I recall this correctly, yes, it is. That describes your physical configuration of your hardware. It says with which hardware you have or which platform you are basically connected to, what's the current state of the system is. What else do we have? What your ISO file is from which you installed in this case. Of course, the name of the VDI file, which snapshots you have. You recall you can take snapshots. Which devices are virtually attached to your system. For example, sound drivers, which hardware drivers and hard disks are connected. So that's kind of the unique identifier for the hard disk, which points back to the VDI file that is saved. Hang on, where is this? See if I find it here. Yeah, it's the key pointing to this entry here. And this actually points back to the Ubuntu 18.04 VDI. So, and it says, well, format VDI. That's your hard drive, basically. What else do we have? Yeah, that's basically it, right? So it says which devices are connected to it, which format it is in, and where it's roughly located. And those two files basically make up your entire virtual machine, right? If you copy those once to your USB stick, copying to external hard drive, copying across network sites, whatever else, you can replicate your entire infrastructure there. That's the key idea. And that's roughly how it works in the in data center settings as well, right? So that they have basically baked down the entire system to an image, because that's the idea about virtualization, representing your hardware in software, and that's how they fundamentally do it. That's how they can migrate your system. The magic, however, and that's where your question is really sensible, particularly sensible, is they sometimes need to do live migration. So if the system is still running, they still need to copy it. And that's a non-primitive task. If you need to copy basically a system while it's still running. So, but that's a different side. Please, you have another comment. So again? Well, that could possibly happen. They will most likely keep in the same data center, but most likely not in one single allocation, right? So if you're only using, for example, 25 gigabyte of your 500 gig allocated data, they will allocate initially those 25 gig you're actually using plus X. But if you require more allocation, that may not be contiguous, meaning it doesn't necessarily sit on the same hard drive, but maybe on a different hard drive, but maybe would be linked virtually, so it appears as if you're actually working on the same hard drive, if that makes sense, right? So that's the idea there. But that's right. So those images are baked down to your space that you actually use, not the allocated space. That's a good question. So right now, if you look at the image is well, roughly 10 gigabyte in size. But if the system has, in principle, allocated 25 gigabyte, you wouldn't see that here. It would be just subject of the configuration file, because it only shows how much is actually allocated and physically used. So that's an example of thin provisioning. In fact, we could look back into the file and have a brief look. Anyway, I think I'll give you a bit of a break until, as I violate my promises again, until 35 or something. Does that make sense? Yeah, good. Until 35. While I figure out how much provisioning I did here, actually.